So this is section 4.1.2 for integrated 2. We're going to continue factoring. This time, though, we're going to use area models as opposed to the algebra tiles. So this is that generic rectangle. One of the things that's important to note, we always want to make sure that our quadratic is in standard form. So basically, you want to talk about being in descending order, which means that the variable with the largest exponent is going to come first. So if we're talking about a quadratic is always of the form ax squared, where a is just a number, bx, where b is just a number, and then plus c is a constant, and that's just a number. It is important to note, though, that a, b, and c can basically be anything you want them to be, as long as they are real. You and I will talk about numbers that aren't real later. And you don't want a to be 0. If a is 0, then your x squared term is gone. So it's no longer a quadratic. Now it's linear. It's just an x and a constant. So now we're looking at a line. So we just want to make sure that this thing is organized. And then it's important to note that that a, so the number that is attached to the x squared for a quadratic, is called the leading coefficient, even if it's not in order. We always think about, if we were to put it into order, biggest exponent first, and by that I mean largest exponent on the variable, we would always think of the leading coefficient being the number that's stuck to that guy. So we want to make sure these are in descending order first, which both of these are, which is good. If they weren't, we'd organize it. And then we want to go through and use the idea of the generic rectangles and the diamonds, like we had talked about previously. So if we have a quadratic, so 3 terms, 2x squared, 5x plus 3, there's 3 different chunks there, chances are this thing is going to go into a 2x2 model. We'll talk about ones that have more stuff going on. But for this one, we're going to be talking about a 2x2 model. So we're going to go ahead and draw that, get ourselves ready, and then start placing things inside. So typically what we do, and this follows the pattern with the book, is that the leading term, so we know the leading coefficient is 2, the x, or the thing that it's attached to, is the x squared. That's going to be our leading term. Typically, that is going to be placed in the bottom left-hand corner. So first thing, first box. Then we go through and we take a look at the constant. That typically gets placed opposite corner from this one. So we're going to go ahead and put the plus 3 there. Okay, now going back to what we had done previously, we'd even talked about, well, you know, somebody talked to you and taught you how to do these diamond problems, but they never told you why. Well, now we know why. What you're going to do is you're going to go back to the area model that you just created, and you're going to multiply along that diagonal. So we're going to go ahead and multiply the 2x squared and the 3. And whatever we get there, that's 6x squared, it is going to go into the top of the area model, which makes sense because the top of the diamond. It's because the top of the diamond always represented multiplication, and we multiplied to get those. Now, we have to figure out what goes in the bottom of this thing. We're going to go back to the original question. The original question says we have 5 x's total to try to make this area model happen. So we're going to put those 5 x's in the bottom, and that's going to represent addition. So now our job is to figure out, well, what are the 2 things that do this? We need to multiply to get the thing in the top, and we need to simultaneously add to get the thing in the bottom. So start thinking about the factors of 6. So I know that the factors of 6 are 1 and 6 and 2 and 3. That's it. So if this is going to work, it's going to be one of those. Well, if I take 1 and 6 and I multiply them together, that gives me the top. That works. But if I take 1 and 6 and I add them together, that's not going to give me 5. That's going to get me 7. That's too much. Hopefully it's the 2 and the 3. So 1 and 6 is out. If I take the 2 and the 3 and I multiply them, yes, that gives me the top. If I take the 2 and the 3 and they add them, yes, that gives me the bottom. But in order for this to work, with getting an x squared when you multiply and x's when you add, these guys need to be like terms. So they're both going to have an x on them. Now, those two things that we found, that 2x and that 3x, they get placed inside the empty boxes back in the area model. It doesn't matter which one. So you can choose to put the 2x in the top box or the 3x. Doesn't matter. You get the exact same answer. So put one into one of the empty boxes, one into the other. Okay, now there's this pretty slick pattern that happens, and this is one way to check and make sure your area model makes sense. Remember back to when we multiplied the 2x squared and the 3, and we got that 6x squared, that orange one. If your area model is correct, then the other diagonal must also multiply to give us 6x squared. And it does. So that's good. That's just a quick check. Now we're back to what we did previously. So we need to figure out what the base and the height of all of these boxes are. So if we take a look at the first one, I've got this red base here, which we know is going to be the same base length across there and the same base length across the top. So now we're going to divide. So if we divide, we have a 2x squared and a 2x stacked on top of each other. The GCF that they both have in common is a 2, but they also have an x. Okay, so I think our red length is going to be x. Then, let's see if we can finish off this box on the bottom left. So if I know that the base of that is going to be 2x, and the area is 2x squared, the only thing that'll actually make that work is a 1x, which means all of these purple lengths are exactly 1x in length. So should look familiar from what we've done previously. All right, let's see if we can find the base, so yellow, of the 3x box. All right, well, it looks like it's got an x height, an area of 3x. I think that's the only way that's going to work is with a 3. So we know that the base length across the top is going to be 3, and then across the very, very top is going to be 3. Last thing we need to do is figure out what the last heights are. So if the yellow length is 3, and the area of the top right corner is 3, that means that gray height, I believe, is going to have to be 1. So let's go ahead and put a 1 out there. And then double check the box that you haven't looked at yet, which is the top left. So we've got a 1 height and a 2x base. If we multiply those, we do get 2x. Okay, I think we've got this. So across the bottom is going to be 2x plus 3, and up the side is going to be x plus 1. So same process for the next one. Go ahead and see if you can set it up. Pause now, but I will work through this one with you as well so you can kind of see what we're doing. But I do want you to give it a shot yourself. Okay, so I set up my rectangle. I check to make sure that my quadratic is in standard form. Take the first term, put it in the bottom left-hand box. Take the last term, put it in the box opposite that. Do a quick multiplication on those guys and see what those give me, which is 24x squared. Okay, let's go ahead and set up the diamond problem off to the side. All of these are just tools, just so you know. So just supposed to help you, not supposed to create extra work. So we have 24x squared for the multiplication. All right, let's go back to the question now. I know that I only have 10x tiles to actually make this happen. So 10x goes in the bottom. That is going to represent our addition here. All right, think about the factors of 24. So I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. I think that's it. Start going through these. 1 and 24, that's not going to work. 2 and 12, maybe if there was a negative sign, but no, I don't want to subtract them. 3 and 8, nope, looks like it's going to be 4 and 6. And they do have to be like terms. Make sure there's x's on both of those. Put them into the empty boxes. Remember, it doesn't matter which one goes where. Do a quick multiplication check on that diagonal as well. You got to make sure that you get 24x squared, which you do. All right, now we figure out the bases of these and try to start factoring. So if I look there, that length is going to have to be the same all the way up. Okay, so I'm going to look and see what they both have in common. 3 and 4, well, the only thing that goes into those is 1. An x and an x squared, though, that's an x. So we've got something that we can take out. All right, so now let's move on. Let's see if we can find the height of the bottom box. All right, in order for that to work, we know that the length, or the base is x. We know the area is 3x squared. I think the only way that's going to work is if that's a 3x. So that means that this dark purple length all the way across is a 3x. All right, that means that we can actually go through and try to find the base of that box. All right, so we've got 3x as a height. We have 6x as the area. I think that's going to have to be a 2 for this to work. And then that gray length is 2 all the way up. All right, doing the exact same thing, trying to fill in that last box. So if the base of the gray box is 2 and the height, well, it's the yellow, well, we've got an area of 8. I think the only way that's going to work is if this yellow height is actually 4. So I'm going to put my 4 out here. Do a quick check, make sure the top left box works. Actually, make sure all of them work. There's no negative signs, so the whole thing should be addition. So the base times the height. All right, there we go.